This screencast is on the use of scientific notation in chemistry. I expect that you have already dealt with scientific notation in your math classes and that you know it is a way of expressing really big numbers or really small numbers without having to write so many zeros. I find a lot of students write scientific notation improperly. The way scientific notation should be written is that it is a number between 1 and 10. And then you have a power of 10. So n is your number, and that number needs to be between 1 and 10. So it shouldn't be less than 1, and it can't be more than 10. And then it's times 10, and then you're going to raise that 10 to some power. And that power has to deal with how many places you move the decimal. To change from standard form to scientific notation, you're going to want to move the decimal so that you have a number between 1 and 10. Count how many times you had to move the decimal. If it is a large number, then the exponent remains positive. If it is a small number, then the exponent will be a negative number. That just means, again, that's not a negative value all the way. That just means that it's a small number. So here we have a few examples. This is a very large number. If a decimal is not printed, you know that it is at the end of the number. And now we're just going to move the decimal until we get a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8. Now I have a number between 1 and 10. I had to move the decimal 8 places, and it is a large number, so that exponent would remain a positive number. So, moved 8 places. So the way this would work is it's 2.898 times 10 to the 8, and then whatever units it should be. Here we have a small number, and so we're going to do the same sort of thing. Here we can see the decimal, and we're just going to move that until we get a number between 1 and 10. 1, 2, 3. We can't stop there because I don't have a number between 1 and 10. 4. So 5.67 is a number that is between 1 and 10, and I moved the decimal 4 places. This is a small number, so that's why I made it negative. Alright, now going the other way, if you get something in scientific notation and need to go to standard form, you know that the exponent of the 10 means how many places you're going to have to move it. If it is a large number, then it is a positive exponent, so you need to move the decimal so that you end up with a large number. And if you have a negative exponent, then you're going to move the decimal so that you end up with a small number. If we look at this one, we have 5.093 times 10 to the 6. This is a positive exponent, so this means this is a big number. So I need to move the decimal 6 places. 1, 2, 3, 4, 5, 6. And then you're going to fill these guys in with zeros. And you would end up with this. Here we have a negative exponent. That means this is a small number, so I'm going to move the decimal so that I end up with a small number. I'm going to move it 4 times. 1, 2, 3, and 4. And again, you would fill in all those spaces with zeros. And so your answer would look something like that.